Hello and welcome. Have you ever really stopped to think about what's going on inside your phone when you power it on? It's kind of amazing, right? In just a blink of an eye, it's on a 5G network ready to go. So today, we're going to pull back the curtain on that super fast, super complex conversation that happens between your phone and the network. We'll use the 5G standalone call flow to guide us. All right, let's get into it.
I mean, it really does feel instant, doesn't it? You hit the power button, and bam, you're streaming videos, you're browsing the web, you're connected. But behind that totally seamless experience, there's this lightning-fast flurry of requests, authentications, and negotiations going on. So what on earth is actually happening in those few seconds?
So here's the plan. We're going to follow your phone's journey right from the moment it wakes up. First up, we'll look at the first handshake, how it says hello and introduces itself. Then we'll see how it actually gets online by opening the data tab. After that, we're diving into how the network gets sliced up to give you a great experience for whatever you're doing. And finally, we'll see how your phone cleverly manages its connection to save that all-important battery life. Let's kick things off with that first introduction. All right, section 1. The formal introduction. Before your phone can send a single tweet or stream a single song, it has to find the network and basically ask for permission to come on in. This whole first step is all about building trust and verifying its identity. Just imagine you're walking into a really crowded, noisy room, and you need to get the host's attention. You can't just start yelling, right? Your phone's in the same boat. It can't just start blasting data into the air. It has to follow a very specific, almost polite procedure to make its presence known and to get a response. So what happens is this really cool multi-step dance. It all starts when the phone sends out a random access preamble, which is basically a little wave, a quick, "Hey, is anyone out there?" The network hears it and sends back a response, giving the phone its own little time slot to talk. The phone uses that slot to make a formal RRC setup request. The network says OK with an RRC setup message, and then finally, the phone sends over its full registration request, all bundled up inside an RRC setup complete message. And just like that, the handshake is done. But let's peek inside that final message, because this is where the phone really lays its cards on the table. It says, hey, this is an initial registration. It provides its identity using something called a SUSI, which is super important because it keeps your identity private over the airwaves. It also tells the network what kind of services or slices it's interested in, and it lists all its own capabilities. It's pretty much the digital version of walking up to a security desk and showing your ID and your special access credentials. Okay, so our phone is now officially recognized by the network. It's in the club. But it can't actually do anything useful yet. It's not on the internet. To get there, we need to open the data tab. And this happens through something called a PDU session. Now, the easiest way to picture this is like a dedicated secure water pipe running all the way from your phone to the big ocean of the internet. Until that pipe is built and the tap is turned on, no data can flow. Establishing this PDU session is the exact moment your phone gets its IP address, its unique street address on the internet. So the network gives the final green light by sending a PDU session establishment accept message. And this message, it's the absolute key to everything. It's so important because it's got the IP address for your phone, but it also lays down the law with quality of service rules. These are basically the terms and conditions for your data connection. Your phone gets this message, sets itself up, sends back a quick, got it, and boom, the data tab is officially open for business. Now that the pipe is open and data is flowing, how does the network make sure your Netflix stream is buttery smooth while your emails are still syncing in the background? Well, the answer is one of 5G's absolute killer features, network slicing. This is a huge challenge for any network, really. Not all data is the same. A video call can't handle any delay, but a system update can take its sweet time downloading. So 5G is smart about this. It treats different types of traffic differently right from the get-go. The idea here is actually pretty simple, but it's incredibly powerful. Instead of having just one giant, one-size-fits-all network, operators can create multiple virtual networks, or slices, all running on the very same physical equipment. Think of it like a highway. Instead of every car, truck, and bus being stuck in the same traffic jam, you can create a dedicated express lane just for ambulances, and maybe another one just for high-speed traffic. The standards actually define three main types of these slices. The first one you can think of as that high-speed express lane. It's built for stuff like streaming 4K video and online gaming. That's called eMBB, or Enhanced Mobile Broadband. Then you've got this ultra-reliable, super low delay lane. This is for things that absolutely cannot have any lag, like self-driving cars talking to each other or maybe remote surgery. That's called URLLC. And finally, there's a slice designed to handle billions of tiny, low-power devices all at once, like sensors in a smart city. That's called MIoT. This is what makes 5G so revolutionary. It's not just faster, it's smarter. Okay, so our phone is connected, it's online, and it's in the perfect network slice for what we're doing. But if it kept that high power connection running 24/7, your battery would be dead in no time. So how does it stay ready to go without just killing the battery? The secret is something called RRC state transitions. This quote here, it really gets to the heart of it. Your phone isn't just on or off. It's constantly, intelligently shifting between different states of readiness to perfectly balance performance with power saving. The two most basic states are idle and connected. This table really breaks it down nicely. So RRC connected, that's when you're actively using data. Your laptop is on, screen's lit up, you're working. Simple. Then there's RRC idle. That's for maximum battery saving when nothing's going on. Your laptop is totally shut down. But here's the genius part that 5G brings to the table. RRC inactive. This is the perfect middle ground. It's just like putting your laptop to sleep. It uses almost no power, but it can wake up and get back to full speed almost instantly. It's the best of both worlds. And switching between these states is all handled by specific procedures. To go from totally idle to active, it uses that RRC setup procedure we talked about at the beginning. When you stop using data for a bit, the network sends an RRC release command to pop it into idle or inactive mode. And to wake it up from that power-saving inactive state, it uses a super fast RRC resume procedure. It's this incredibly smart dance happening in the background that gives you both that instant connection and a battery that lasts all day. So let's just do a quick recap of our phone's big journey. It all starts with a secure handshake to get its foot in the door. Then it establishes a PDU session to get an IP address and open up that data pipeline. The network uses slicing to make sure the quality of service is tailor-made for what you're doing. And the whole time, these RRC states are working quietly in the background, shifting your phone between active, sleep, and idle modes to give you performance when you need it and battery life when you don't. You know, what's amazing is that we've only just scratched the surface of one single process. Every single second, your phone is also managing things like beamforming, handling seamless handoffs between cell towers, and doing countless other invisible tasks. It's just an incredible reminder of the amazing engineering that's constantly at work right there in the palm of your hand. Thanks for coming along on this deep dive with me.